Welcome to another episode of the FreeTAK team. In this series, we are introducing some of the concepts that we use to develop FTS 2.0. And this time, we are going to discuss the Digital Pi multiprocessing architecture. If you are not familiar with Digital Pi, please watch the previous videos that introduce what Digital Pi is and also our component architecture. So let's go into it. So with FTS 2.0, we are implementing a complete asynchronous and scalable system for a high performance architecture that we can scale out with the amount of available resource as advanced network capability, supporting concurrency, and we can carry messages across various transport like interprocess and TCP. So what is the magic behind all those concepts? Is a library called ZeroMQ. And ZeroMQ is a kind of socket or super socket or socket on steroid that we use for the communication. So if you remember the architecture of Digital Pi, on the very front we have something called a service. So a service can be a TCP service, a SSL service, a protobuf service, and exposes a port to the outside world. So, and over that port, we receive a message in a certain technology. For example, could be or language, can be a XML message or a REST message. But independent from that, the service will translate that language and then push to the so-called subject. The subject is like a load balancer that will simply allocate the content of the message received by the service to one of the workers. So we can have any number of workers, and that means that the scalability of the system is only limited by the amount of physical resources that you have in your current installation. Namely, you can install all of that on a simple Raspberry Pi, or you can install on a machine with a very high amount of cores, and each of those worker will be allocated to a certain CPU and perform everything in parallel. So the subject will pull the information from the service and push to a available worker. The worker will provide all the components. For example, worker 1 here is trying to solve the emergency. So emergency is one of the features of a FTS worker 2 is doing something with check, and worker 3 is performing some core activities such as login, logout, and so on. So when a worker finish his job, we'll push the information to the integration manager. The integration manager will pull the information, then publish it to all the different pieces of the system that are subscribed to a certain type of message. So for the more technical people here, you can notice that we are using different patterns, so push and pull and pub and sub. So pub and sub is a mechanism that will allow us to scale up to thousands of workers potentially. But then also the server itself is subscribed to certain topics, and so the response to the original message will go over this chain and then return here because the server is subscribed, and then the message will be sent back. So the advantage of this architecture, as I said, is scalable and is completely asynchronous. So we have not blocking processes. Even if one part of the system will go offline, the rest of the system will continue to perform its duties. Additionally, that is not yet in the pipeline, but it's a potential feature. We can implement the worker in any language, and that means that not only we can allocate this to a different node, but could be a complete different implementation. FTS is implemented in Python, but for certain nodes we may want to have high speed implementation like in C or C++ or any other language that is supported by the 0NQ framework. So that is the conclusion of this short video on our architecture that is asynchronous and scalable, and that is planned for FTS 2.0. Thank you, and watch the other videos in the series to learn even more about the new architecture and the new functionalities of the system.